In this video, we're going to talk about the basics of polynomials, some very basic information that you will need to know in order to work with them successfully. So the first thing you probably want to know is what exactly is this fancy word, a polynomial. Now, a polynomial is nothing more than an expression, and an expression with a couple of criteria met. The two criteria are the expression has whole exponents on the variables, and the coefficients to the terms are real. Now, we haven't really talked yet about imaginary numbers, but that's what that would exclude. So if you have an expression that meets these two criteria, what we have is a polynomial. Standard form of a polynomial will take those terms and place them in a specific order. The terms are ordered in decreasing degrees. So if you have a cubic term and a linear term, the cubic term would appear first when you're talking about standard form. Okay, so when I'm talking about the degree of a polynomial, I am talking about the degree, or the highest degree, of any term. Okay, so the first task that you're going to have to do with polynomials will be operations, adding, subtracting, multiplying, and we're probably not going to divide quite yet. But when you are adding and subtracting polynomials, there's really three steps. The first step would be to, if you have a subtraction problem, you're going to distribute the negative through the expression, okay? So if you're adding, this does not apply because there is no negative in front of any expression. The next thing you're going to do is combine any like terms, okay? And remember that a like term has the same variables at the same power, okay? So x squared and x squared, or x squared and 3x squared, these would be like terms. But if I took x squared and y squared, these are not like terms, nor is 3x and 5x squared. They need to have the same variable, and they need to have the same degree on that variable. So distribute that negative through the expression, combine your like terms, and then write it in standard form. So let's take a minute and do a couple of examples where we are adding and subtracting. Okay, in this case we're just subtracting a couple of polynomials. So that first step would be, let's distribute the negative through the following expression. Okay, so I'm going to just rewrite this whole expression, and when I do that, I'm going to remove my parentheses by taking that negative and distributing it through. Notice that there is nothing in front here, so I can just drop these parentheses. 13x cubed minus 9x squared minus 7x plus 1 minus a negative 7x means plus 7x minus a 2x cubed equals minus 2x cubed minus 9, and minus a negative 5x means add that 5x. Okay, so now what I want to do, I want to combine like terms. And I'm going to combine like terms and write in standard form in one step. Since I know that I'm looking for my highest degrees first in standard form, I'm going to look for my highest degrees first. I see a 13x cubed and a negative 2x cubed here. So that becomes 11x cubed. I see a negative 9x squared, and that's the only x squared term that I see. So I'm going to make that 9x squared right here. Now I'm going to look for my linear terms, anything that has an x. I have a negative 7x, I have a positive 7x, and I have a 5x. Well, we know that negative 7x, that positive 7x cancel out, so I'm just left with that 5x. And last, I've got constant terms, the terms that don't have any variables. I have a positive 1 and a negative 9, otherwise known as negative 8. All right, so what I have done here is I have subtracted this polynomial from this one, and the result is this polynomial, 11x cubed minus 9x squared plus 5x minus 8. All right, let's do the same thing with this next polynomial. And you notice that this polynomial has both x's and y's in it. So let's do the same thing. Let's distribute this negative all the way through this polynomial, and let's just drop our parentheses here. So we have x cubed minus 4x squared y plus 5xy squared minus y cubed plus 6x squared y minus x cubed. Okay, so now I just have this long string, one polynomial expression, but it's not combined and simplified. So let's look at let's start with our x's, and we'll just go down in order here. So we've got x cubed and a negative x cubed. Those cancel out completely. Here I have a negative 4x squared y, and here I have a positive 6x squared y. So that would become just a positive 2x squared y. Here I have a 5xy squared, and there is no other term that is like that. So I'm just going to put that down here, 5xy squared. And then I have two terms left. Lucky for me, they both have y cubed in them. I've got a negative y cubed and a negative y cubed. Well, that's two negative y cubes, right? All right, and then I have a solution for my polynomial. Okay, so now let's talk about how do we multiply polynomials. Anytime you've got more than one term multiplied by an expression that has more than one term, you have to take each term in the first and multiply it by each term in the second. So if we're looking at a binomial here, two-term polynomial, and a trinomial right here, we're going to take this term, the first term in the binomial, multiply it by each of these three. Then we're going to take the second term in the binomial and multiply it by each of these three. Then we'll have this long string of terms that we need to combine and simplify into a standard form version of a polynomial. So let's give it a whirl. Let's take this one, 5x, and multiply it by each of these things. So 5x times 3x squared gives us 15x cubed. 5x times negative 5x gives us negative 25x squared. And 5x times 4, that gives us 20x. This negative 2, if I multiply it all the way across, I've got negative 2 times 3x squared. That gives me negative 6x squared. Now I can put this on the back here as a long string, but I prefer to put it just right underneath here, negative 6x squared, because these are like terms. I'm grouping them as I write. Negative 2 times negative 5x is negative 10x, and the negative 2 times 4 gives me negative 8. Now if I combine the like terms, notice that I have grouped them already. I can see what needs to be put together, and I end up with 15x cubed minus 31x squared plus 14x minus 8. And that would be my solution when I multiply these two polynomials together. Okay, for this next example, 5x minus 6, the quantity is being squared. I have to remember that when I'm squaring something, I'm really multiplying it by itself. So what I really want to do is say 5x minus 6 times 5x minus 6, and then do the same thing as I did before. Take this 5x and multiply it to both terms, then take the negative 6 and multiply it to both terms. So let's do that. 5x times 5x gives me 25x squared. 5x times negative 6 gives me negative 30x. Now I start with the negative 6 term here. Negative 6 times 5x, that's another negative 30x. And the negative 6 times negative 6 is positive 36. So combine our like terms. 25x squared minus 60x plus 36 gives us our final answer. Okay, so for this next example, doing the exact same thing, and we're going to see something unusual happen here. Let's go ahead and try. Okay, we ready? 4x squared times 4x squared, that gives us 16x to the fourth. Remember that when we multiply bases that are the same, we add these exponents. So 16x to the fourth. Now 4x squared times 3, that's a positive 12x squared. Then we're going to come to this negative 3 and work through. So negative 3 times 4x squared, that gives me a negative 12x squared. And the negative 3 times positive 3 gives us a negative 9. Adding our like terms, 16x to the fourth. What happens here? Positive 12x squared, negative 12x squared. These terms cancel out, and I'm just left with the minus 9 as my answer. Now, it's worthwhile to point out, you're going to see this pattern over and over again this semester. When you have something A plus B and A minus B multiplied together, you're always going to end up with those middle terms canceling. So it's probably worthwhile to, if you can remember this pattern, A plus B times A minus B. All right, the A's, let's just multiply this out, just the variables. A plus B, A minus B, I have A times A squared, A times negative B, negative AB. B times A is AB, and B times negative B is negative B squared. And these, of course, are going to cancel, and so you're always going to be left with A squared minus B squared. So if you've got two binomials, and they have the same terms in the binomials but different signs, you're always going to end up with the first term squared minus the second term squared, always. So that's just a worthwhile pattern to commit to memory. You can always multiply it out, but you're always going to get this answer. Okay, last, let's take a look here. 7x minus 6y times 3x minus y. Same idea, except here we have two different variables going on. You don't handle it any differently. You're just going to multiply the 7x to both, then the 6y to both. Sorry, negative 6y. So 7x times 3x gives us 21x squared. 7x times negative y, negative 7xy. Negative 6y times positive 3x, negative 18xy. And a negative 6y times a negative y. That would be positive 6y squared. Okay, so let's add our like terms. We have 21x squared, negative 25xy, and positive 6y squared. And that, in a nutshell, is basics about polynomials and how to do some basic operations. We will talk about dividing polynomials at a later time. See you next time.